Here's our net reaction. Let's talk about how to take this net reaction and break it into two half reactions. The half reactions will involve the change in the oxidation state of only one of the substances involved, and the half reactions will contain the actual electron that is lost or gained by the species. The first half reaction will be the oxidation of zinc to form zinc 2+. Notice that I'm not done writing the reaction. It's not balanced in terms of its charge. The zinc solid is zinc 0. The zinc 2+, it has a 2+ charge. In order to balance the reaction, I need to put 2 electrons on this side so that the product side is neutral when you sum the 2 positive charges on the zinc and the 2 negative charges from the 2 electrons. The next half reaction is the reduction of copper 2+ to form the copper solid. When we sum these reactions, you'll notice that the electrons cancel out and we return the total net reaction that we started with. So now I'd like to talk about the mechanism of this particular redox reaction. I've drawn the net balance reaction at the top, and then here at the bottom left I've drawn a little cartoon showing a chunk of solid zinc in a solution of copper 2+. So there are a bunch of zinc atoms in the solid chunk of zinc, and the vertical line represents the surface of those metal atoms, and then there's a copper 2+ solution with copper 2+ ions diffusing around. The first step of this reaction is that the copper 2+ ions bump into the surface and absorb. The next step is an electron transfer from the zinc atom to the copper 2+ ion that's adsorbed to the surface. So 2 electrons get transferred from one zinc atom to the copper 2+ ion that's adsorbed to the surface. Once the electrons have been transferred, the zinc is actually now a 2+ cation, and the copper is 0. It's now metallic. So what that means is that the actual surface of the metal now incorporates the copper, but then this zinc 2+ is actually an ion. So the ion is soluble in the solution, and the copper 0 is now metallic copper. It is not soluble in the solution. So the next step is that the zinc 2+ desorbs from the surface. Once the zinc 2+ desorbs from the surface, it then diffuses out into the solution. What you would see if you conducted this experiment is you would start with a bluish solution of copper 2, and then you'd put a shiny zinc wire into it. Over time, the zinc wire would accumulate copper onto the surface, which may look black or hazy, and the solution would turn from blue to clear as the copper left the solution and adsorbed and plated onto the surface. The solution would also increase in zinc 2+ concentration as the reaction progressed, as the zinc was oxidized and desorbed from the surface into the solution.